Hello and welcome back to the third video in this series where I'm going to be going through all of the exam style and problem solving questions from the A-level Edexcel textbooks. So I'm starting with the year 2 content, and today is going to be section 9.3, which is differentiating using the chain rule. Now if you haven't already, please consider subscribing to the channel if you'd like to see more of these videos. If you have any suggestions of what you'd like to see in the coming weeks, please leave a comment down below. And if you'd like to hear more from me, please consider subscribing to my social media, Instagram, TikTok, in the description, as well as joining the Discord server where you'll be able to connect with like-minded individuals like yourself who are preparing for their A-level exams, as well as get more updates on the content I'll be posting. If you're interested in private tuition as well, please feel free to contact me using my contact details in the description. Without further ado, let's do some differentiation questions. So I thought we'd start with a little recap before I jump right in today. So we're going to recap the chain rule. So all the chain rule is saying is if you want to find a derivative dy by dx, it's possible that if you're able to find some function of a function, and I'll explain that in a second, then you could instead find du dx and multiply it by dy du, where this u is some substitution that you choose. And it's normally quite obvious. Normally you have some function of a function. So what do I mean by that? What I mean is, let's say you had sine of 2x. Now, if you want to differentiate that, hopefully you will know by this point that it goes to 2 cos of 2x. But the reason, or one justification for that, is because of the chain rule. Now the function of the function here is the fact that you have your first function sine, and the second function is a very simple one, it's just 2x. So that's what I mean when I say function of a function. So the very natural substitution to make here would be if I say that y is sine of 2x, then my u in this case would be 2x. So for that matter I have y is equal to sine of u. Right, so that means if I find dy by du, it's just cos of u. But if I remember from the formula, I also need du by dx. Now u is just 2x right here, so du by dx is equal to 2. So if I bring this all together, my dy by dx is going to be 2 times dy by du, which is cos of u. But we obviously don't want to leave it in terms of u. We've just made that up ourselves, remember? Like, there was no u before we started this question, so we'd better put the 2x back into here. So this is 2 cos of 2x, which is exactly what we expected, because you already know how to differentiate sine of kx. Okay, so that's the basics down. Hopefully you remember that. If you don't, please go and check your textbooks. It's quite important. If you do, then let's get on with the questions. And once again, please make sure you try these questions before you watch them, unless I guess you're spending your last final minutes before an exam. But give them a go. If you get stuck, play the video until the point where you're not stuck anymore and see if I resolve your problem. and then pause it again and finish the question. Okay, let's start. So the first question of interest, so this is all from exercise 9C, by the way, in the year 2 textbook. A curve C has equation y is equal to 5 minus 2x all cubed. Find the tangent to the curve at the point P with x coordinate 1. So y is equal to 5 minus 2x cubed. So with a question like this, you could be tempted to expand, but that's obviously going to be very cumbersome, and I wouldn't recommend it. So it's normally easier to see you need to use the chain rule when this is bigger than 3. Say if it was 10, then you really wouldn't want to expand it. So the key here is we want to see that this is the function on the inside, and then the overall function is the cubic function. So if we let u equal 5 minus 2x cubed, then you have y is just u cubed. So remember that dy by dx is du by dx times dy by du. Then we're going to get, well, dy by du over here is just 3u squared. And then we can easily see that du by dx is equal to minus 6x squared. So putting it all together, and maybe I'll just write in what u is already. I'll leave it a second. So we're going to get dy by dx is du dx, which is minus 6x squared, times dy by du, which is 3u squared. Okay, plugging back in for u and combining the 6, minus 6 and 3, I'm going to get minus 18x squared, lots of 5 minus 2x squared. Okay, so that's the derivative. I didn't really mention why I was doing that, but because we want to find the tangent to the curve at point P, we obviously need to work out what the gradient is, and to do that we need the derivative. So the tangent to the curve at the point P with x coordinate 1, alright, well we can now find out what the gradient is there, because we have the derivative. So at x equals 1, we want dy by dx of 1, so I just need to plug 1 into here. So that's going to give me minus 18 lots of 5 minus 2 all squared. So this is just 3. 3 squared is 9, so this is going to be minus 18 times 9, which is going to be minus 162. Okay, oh, there we go. So, okay, now I've got the gradient. I want to find the tangent to the curve at point P with x coordinate 1. So I know that my tangent is going to be of the form y is mx plus c, because it's just a straight line. I now know the gradient, so I know that that's actually y is minus 162x plus c. Fantastic. Okay, but now if I want to find the c, I need to know a full point on this line. So the best point to pick is going to be when x is 1. So I need to know the y coordinate when x is 1. Well, we're also on the curve, so I can therefore find the y coordinate. So it's going to be, the y coordinate is, when x is 1, is 5 minus 2 lots of 1 cubed. Okay, so 3 cubed, that's 27. So 27 is equal to minus 162, and I've just substituted in 1 here, plus c. So c is going to be, let's make sure I don't make a mistake now, 162 plus 27, 189. So the tangent line is going to have equation y is equal to minus 162x plus 189. Okay, hopefully that was all clear. These questions are always the exact same. If you ever need to find a tangent, you just need to find the gradient at the point. You also need to know an x and y coordinate on the tangent line. And the easiest one to find out, and kind of the only one, is the one that's also on the curve where it's touching. So you just substitute the x into that y function here in order to find the y coordinate. Okay, any questions, leave them in the comments or contact me directly. Let's continue. So this is question 5. So again, you can see we've got a function of a function set up. So given that y is 1 plus the natural log of 4x all to the power of 3/2, find the value of dy by dx at x equals a quarter e cubed. Okay, so they've given us an interesting value of x here. So let's write it out. Y is 1 plus the natural log of 4x all to the power of 3/2. We want dy by dx, so what are we going to do? Well, it's kind of obvious again, we should probably call this u. So I'm going to let u equal 1 plus the natural log of 4x. And then we have y is equal to u to the 3/2. So again, we want dy by dx. That's going to be du by dx times dy by du. Okay, so we just need to find both of those things. So du by dx over here is going to be 1 over x. So, okay, I could use the chain rule again here, but if you remember, actually in the last video we saw that differentiating log of kx just gives you 1 over x still. To see that, if I do 1 over 4x, then I have to multiply by the derivative of the inside, which is 4. So this is the chain rule in disguise again. It's going to give me 1 over x. If you're not convinced of that, do it yourself properly. Consider this on itself and make a u substitution here and use the chain rule. So that gives me 1 over x. dy by du is 3/2 u and then to the 1/2, right? So putting it all together, I'm going to have dy by dx is equal to du dx, which is 1 over x, times dy du, which is 3/2. I'm going to substitute the u in already. 1 plus ln of 4x all to the power of a half. So we're not done. We wanted it at x equals a quarter e cubed. So let's put that in. We're going to get dy by dx is equal to 1 over x times 3/2 1 plus ln of 4. Sorry, and that means I need to plug the x's in, don't I? So the x is a quarter e cubed. So 1 over a quarter e cubed times 3/2 1 plus ln of 4 times a quarter e cubed all to the half. Okay, so if I simplify this, this is going to turn into 4 over e cubed, and then I'm going to times it by 3/2. So the 4 and the 2 are going to cancel. I'm going to be left with 2 on the top and a 3. So convince yourself that this first bit is 6 over e cubed. Lots of 1 plus, now this is the natural, 4 1/4 cancel out, so this is just the natural log of e cubed. The natural log tells you to which power is the argument, well, to which power is e raised to give the argument. So in this case it's easy, e is raised to the power of 3, so the answer to this is 3. Okay, so I'm going to get 1 plus 3, which is just 4, to the power of a half, which is just the square root, so that's 2. So 6 times 2 over e cubed, 12 over e cubed. And if you really wanted to, you could write it 12e to the minus 3. And it hasn't told us anything else. Maybe it could give you, you could say give it to 3 significant figures. Probably unlikely. This is the exact value. Okay. Right, so, okay, question 6. These are problem solving questions. I'm not going to do all of these. I will do the kind of odd ones. So I'll do A and C. If you're interested about the solutions to the other ones, again, get in touch. So we want to find dy by dx for the following curves giving your answers in terms of y. So there's one thing I didn't mention here, is that due to the chain rule, we have dy dx is the same as 1 over dx dy. So this is another thing that you want to remember, and it's what we're going to use for this question. So what you should try and do is derive this from what you know about the chain rule and see how you get on. I think it is in the book as well, but try and do it yourself and see what you get to. So, okay, let's start with part A. So we have x is y squared plus y. So clearly it's not going to be easy to try and rearrange for a y here. So we don't want to do that. So the point is instead, let's just find dx dy first. So this is looking at x as a function of y, which I know this looks weird. So that's just going to give us 2y plus 1. Then dy by dx is 1 over that. So it's 1 over 2y plus 1. And it's asked for the answers in terms of y anyway. So this is it. Okay. I'll do part C. So question C, x is equal to the sine of 2y. So they're not very long, these, I guess, are they? I probably could just do all of them, but I'll let you try the other ones. So x is sine of 2y. That's going to give us dx dy is equal to 2 sine, not sine, 2 cos of 2y. Which means dy by dx is 1 over that. So it's going to be 1 over 2 cos of 2y. And if you want to write it in a nicer form, you can do a half sec of 2y. I mean, in an exam, it would probably tell you how they want it to give it to you, but this is slightly cleaner. Okay, so yeah, try the other ones yourself. They're really not too bad, these. It's a little bit of an irrelevant question, to be honest. There's not too much thought involved, but it is this main thing that they want you to remember. Okay, the next problem solving question is question 7. Find the value of dy by dx at the point 8, 2 on the curve with equation 3y squared minus 2y equals x. Okay, so again here, it's probably easier to not rearrange for y. So do not rearrange for y. And you have to think, well, okay, maybe you would be tempted to in the exam if you saw this, because you want to find dy by dx. But you have to think about how the question is given to you. If it's given to you in this form, it's pretty obvious that they probably would want you to work out dx by dy. It makes a lot more sense. So if we do that, let's write out what x is. So x is 3y squared minus 2y. dx by dy is going to be 6y minus 2. Now, we know that dy by dx then is 1 over that. And because they've given us the entire point, they've given us the x and y coordinate, it doesn't matter that we got it in terms of y. So normally we would substitute the x value in, but we've got a y here. We know which point we want. It's when it's 8, 2, so that means y is 2 here. So all I need to do is substitute 2 into this. So dy by dx evaluated at y equals 2 gives me 1 over 12 minus 2, or a tenth. And I'm done. So actually it wasn't that complicated after all, this question. It was pretty much just do a derivative, but with the y's replaced with x's and vice versa. Okay. A little bit silly, these questions, but it's good to be able to spot those tricks. So question 8, this is going to be the exact same thing here. So really, if you haven't been trying questions already and you just watched the last one, try this one first, because it should be clear to you at this point what to do. So x is going to be y to the half plus y to the minus a half. We want dy by dx. It's given us the whole point. We're instead going to find dx dy. It's going to be a half y to the minus a half minus a half y to the minus 3 over 2. dy by dx is 1 over that. So it's 1 over a half y to the minus a half minus a half y to the minus 3 over 2. And in order to get our answer to this, we just need to substitute 4 into that. Y equals 4. So 1 over a half lots of 4 to the minus a half minus a half lots of 4 to the minus 3 halves. And I'm not even going to bother doing this. I will let you put that into your calculator to find out what it is. Okay. Alright, so back onto the kind of more important, relevant questions here. These are the exam questions. What I might do is, going forward, I might start to remove those questions that just have a P on them, because they are sometimes a bit strange and kind of not as useful, potentially. But please let me know if you think you'd like to see them still, or if you think you'd rather me just stick to the exam questions, because it will mean I'll be able to put out quite a few more videos over the long run. So, okay, what have we got in this question? We've got 9 marks in total here. So the curve C has equation x is equal to 4 cos of 2y. Okay, so it's given us, again, x in terms of y rather than the other way around. It wants us to first show that a point lies on C. Okay, so that's pretty straightforward. If this point lies on the curve, then when I put in the x value of 2, or rather when I put in this y value into the cosine, it should give me 2. So x is equal to 4 cos of 2y. If I do 4 cos of 2 lots of pi over 2, this should give me 2. Not pi over 2, pi over 6. So all I've done there is I've just put the pi over 6 in where the y is. So that's going to give me 4 cos of 2 times, no, 4 cos of pi over 3. This is a half, so that gives me 2. Okay, so point Q lies on C. Okay, right. Show that dy by dx is equal to negative 1 over 4 root 3 at Q. So again, they've given us the y coordinate of the point, which is good because we're probably going to differentiate and find dx dy first. So let's do that. So I'll write it out again. X is equal to 4 cos of 2y. Let's find dx dy. That's going to be negative 8 sine of 2y. So remember, I've used the chain rule already there. Then we want dy by dx, that's just 1 over that. So it's 1 over minus 8 sine of 2y. And it wants us to find that at point Q. So at Q, Q is the point 2 pi over 6. So y is equal to pi over 6. That means I can put that into here. Again, I'm going to get dy by dx evaluated at y is pi over 6 is 1 over negative 8 sine of 2 lots of pi over 6, which is pi over 3. You should remember these, but if not, you can use your calculator. Sine of pi over 3 is root 3 over 2. So this is going to give me 1 over negative 8 times root 3 over 2, which is negative 1 over 4 root 3. There you go. And that is what we wanted. Okay, so part C, find the equation of the normal to C at Q. Give your answer in that form, where those are the exact constants. Okay, so let's make a new page. Little bit annoying that we have to do all this now, but relatively straightforward still. So we want the normal to a curve. In order to work out the normal, well, we need to know what the gradient is at a point, i.e. the gradient of the tangent. We know that, we've just worked it out because we're finding the normal at Q. So we know the gradient of the tangent at Q is that. The gradient of the normal is the negative reciprocal. So in that case, it's just 4 root 3. So the equation of our normal is a straight line, y equals mx plus c, where this is our m. Right, that's the gradient. So the equation must be y is equal to 4 root 3 x plus c. Okay. So if we want to work out what c is, we do the same thing we always do. We need to substitute in the point that we know, which is q. And q is up here, 2 pi over 6. Okay, so let's substitute that in. So that means pi over 6 is equal to 4 root 3 lots of 2 plus c. So c is pi over 6 minus 8 root 3. which means our equation is y is equal to 4 root 3 x plus pi over 6 minus 8 root 3. Now we're not quite done because they wanted us to write it in the form ax plus by plus c equals 0, where a, b and c are exact constants. So I'm just going to put everything onto one side, put it all over to there. So let's have minus 4 root 3x plus y plus pi over 6 minus 8 root 3 is equal to 0. And that is our answer. So this is A, B is 1, and then this whole thing is C. Okay, so multiple parts to that, but all of the individual components are very straightforward. They're just what we've been doing in all of the other chapters so far. This section, sorry. Okay, question 10 finished. So that was 9 marks. So it's certainly doable in a good amount of time. So let's move on to question 12. So this is just 7 marks straight off the bat, no breaking it up. So we've got a curve with that equation. X is not allowed to be a half. We've got a point A that has x coordinate 3. Find the equation of the normal to C at A in that form. So we've basically got the exact same question again, but we've just got a different function. So they like to do this a lot at A-level, where they are really just getting you to do the same things every time. So the process of this question is going to be identical to the previous one. It's just the derivative that we do is going to change. So let's see, y is equal to 4 over 2 minus 4x squared. So first, should we just find the other point at A? So we know it has x coordinate 3. Well, the y coordinate then is going to be 4 over 2 minus 4 times 3. That's 12 squared. So that's going to be 4 over 100. Okay, so 1 over 25. So we'll leave it there, and then let's find dy by dx. So, okay, maybe we want to write y like this to make it slightly easier to see how to do the derivative. Now, some of you may have seen the quotient rule, and sometimes you like to do things like that. Definitely, for this you don't need to do that, and I definitely wouldn't recommend doing the quotient rule in general. I think the product rule is a lot easier to use. But anyway, not that we need either in this case. dy by dx is going to be here. Well, again, we might want to make a substitution here. So if we call this u, that's the natural thing to pick for it. We're going to have u is 2 minus 4x. dy by dx is going to be du by dx times dy by du. So let's work out du by dx is going to be negative 4. Then let's just quickly write y in terms of u. It's going to be 4u to the minus 2. So dy by du is equal to minus 8u to the minus 3. So let's put that all together. We're going to get dy by dx is equal to du dx, which is just minus 4, times dy by du minus 8u to the minus 3. So that's going to give me 32, and let me plug it in back for u now. 2 minus 4x to the minus 3. Okay, so I can write it maybe slightly cleaner like this. Okay, so that's dy by dx. What did we want to do? We want to find the equation of the normal. So in order to do that, we need to find the gradient first of the tangent, and then we can take the negative reciprocal. So the gradient of the tangent is equal to 32 over 2 minus, so at what point are we doing it? We're doing it at point A. So that's when x is 3. So 4 lots of 3. Sorry, that should have just a cube. Okay, so this is going to be 32 over 10 cubed, or 32 over 1,000. So let's just say, right, that's going to be 0.032. Right, so, okay, maybe we don't need to do that, because that means the gradient of the normal is the negative reciprocal, so it's negative 1,000 over 32. Okay, so we have the gradient of the normal, so that means we can say that the normal is the equation of a straight line. Y is mx plus c, and this here is the gradient, so this is the m. So we're going to have y is equal to negative 1,000 over 32 lots of x plus c. And once again, we have to work out what c is, so let's substitute in the full point a. So we know that 1 over 25 is equal to negative 1,000 over 32 x plus c. Sorry, not x. X should be 3 times 3 plus c. That's going to give us c is, let me add that to the other side. It's 1 over 25 plus 3,000 over 32. So it's giving me 9379 over 100. If I put it in my calculator, let me add a page. Okay, so that's C. That means we've got our equation now. So the equation of our normal is going to be negative 1,000 over 32 x plus 9379 over 100. Now, once again, I am just doing all of these questions on site. So if you do find a mistake or anywhere, please do let me know in the comments, as I will be prone to making some of them. So we're not quite done, because they wanted us to give it in this form again. So let's do that. A, B, and C are integers in this case. Oh, let's check if they were meant to be integers before. No, they weren't. Okay, so A, B, and C have to be integers here. So let's multiply everything by, starting to make me think that I might have done something slightly wrong here, because my numbers aren't very nice. In the interest of time, I'm not going to go through and check all of this, but if you do find a mistake somewhere in here with the numbers, please let me know. Otherwise, let's multiply everything out. So I'm going to have to multiply by 132 here. So that's going to give me 3,200. Y is equal to minus 1,000 x plus 9379 times 32. So this does look a little bit odd here, but it could be fine. 3,200 y plus 1,000 x minus 300128 is equal to 0. Okay, but regardless, the process is the same here. So we're trying to find the equation of the normal. So first we find the gradient of the tangent, and to do that we differentiate. After that, we can find the gradient of the normal as the negative reciprocal and put it into a straight line equation. Okay, same process every time. So we should have two more here. We've got question 13 and the challenge. Question 13, find the exact value of the gradient of the curve with equation y is equal to 3 to the power of x cubed at this point. So this is just a differentiation question here. So it's just asking you pretty much, can you differentiate this? So what are you going to do here? Clearly the substitution to make in this case is going to be that u is x cubed. So that we then have y is equal to 3 to the power of u. Now we could go through and try to derive how to do this again, or hopefully you can remember at this point that if y is equal to a to the x, then dy dx is equal to ln a times a to the x, which we worked out in the previous video. So here we have dy by du is going to be ln 3 times 3 to the u. Okay. Du by dx is going to be 3x squared. And again, dy by dx is equal to du by dx times dy by du. Okay, so if we put all that together, we're going to get ln 3 times 3 to the u times 3x squared. And now I should probably put in u in terms of x back into here. So that's going to give me the natural log of 3 times 3 to the x cubed times 3x squared. If you really want to be fancy, you can let this 3 come into here, but we don't really care about that since we're just working out the exact value. So it's at the point 1, 3. So that's where clearly x is equal to 1. That is then going to give us the natural log of 3 times 3 to the power of x cubed. So 1 times 3 times x squared, which is 1. So that's going to give me 3 times 3 times log 3. 9 ln 3. So this was pretty straightforward. It did rely on you remembering how to differentiate the exponentials when it doesn't have a base e. Okay, so almost finished. Let's go into the final question. We've got the challenge. So all the challenges in this case is two slightly more difficult chain rule questions, and I think, to be honest, the reason it's going to be more difficult is because it looks like we're going to have to do a few substitutions. So let's see how that pans out. Start with part A. We've got y is equal to the square root of sine of the square root of x. Now, once you get good at these, you may be able to do the differentiation without explicitly making any substitution. So I'm not going to do that now because I think it will be confusing, but certainly when you have situations like this, it starts to become a little bit less cumbersome to do that. So we kind of have three functions going on here. we've got the main square root, that's function 1. We've then got the sine, that's function 2. And then inside of the sine, we have another function of the x, which is the square root. So this is slightly annoying. And there's a couple of approaches that you could take. I think if you can convince yourself that it's more than okay to, say, do multiple substitutions in one go, and what I mean by that is dy by dx can be dv by dx times du by dv times dy by du in this sequence. This is an extended version of the chain rule, and this would keep on going and going. You can kind of see it by the fractions because these are going to cancel and these are going to cancel if you want to look at it that way. But the other way is to, let's differentiate the inside first and then do the outside, for example. So I think that's probably what I'll do to make things less confusing. And maybe for part B we'll do it the other way. So if we, okay, actually let's do what I said. Maybe this won't be too bad. So if we let, I'm going to let v equal sine of the square root of x, then we have y is equal to the square root of v. Okay, or maybe I'll do v to the half. So clearly we should have that from the chain rule, dy by dx is equal to, and hopefully you're happy, v is still just a function of x here. Dy by dx is equal to dv by dx times dy by dv. Okay. Now the key is that to calculate dv by dx, you're probably going to want to use the chain rule again. Okay, so let's find dy by dv. That's a half v, it's a negative a half. But now we need to find dv by dx. So to do that, we should probably let u equal the square root of x, so we can do the chain rule again. And then we have v is equal to sine of u. So you see how I've kind of done the chain rule of the chain rule here. So again, we can say clearly dv by dx by the chain rule is du by dx times dv by du. Okay, so all I need to do is work those out now. Du by dx is equal to half x to the negative half, and dv by du is just cos of u. So let's put that all together. We get dv by dx is equal to a half x to the minus a half times cos of u. U is root x, so that's going to be cos of root x. So this is just one piece, remember, that goes in to here. Try and make you see that. Right, so I just had to do the chain rule again because I had a function of a function of a function. Now I am done because I can just put everything together. So I'm going to have that dy by dx is equal to, it was dv by dx, so that's going to be a half x to the minus a half cos root x. That was the dv by dx bit. And then we need to multiply it by dv by du. And dv by du was just cos of u. And u was root x. Sorry, no, that's not right. We need to multiply it by dy by dv. This is what I was looking at the wrong thing. So this is what we want. I've just put this in. So I now need to multiply by dy by dv, which is a half v to the negative half. So let me just write it in terms of v first. But we should know, we remember that v was just sine of u. So v to the negative half is the 1 over root sine u. So let's write this as half. We can do 1 over root x cosine of root x times a half times 1 over sine of u, and u was root x, wasn't it? Okay, so if I bring that all together, I should get cosine of root x over 4 root, I bring the x, the root x and the root sine of root x in together. Like that. Okay, so yeah, multiple things going on there. But if you just break it down, all it is 2 different chain rules put together. That's it. So let's try the next one. So let me copy that. So again, we want to find dy by dx. So definitely try this one if you didn't try the last one before I do it. And again, this is what I was saying is you may get to the point where it becomes a bit easier to do these things. So, oh, and this one's actually slightly sneaky because I've just realized that this is a ln y. So first we probably want to write it as y in terms of x. So if ln y is sine cubed of 3x plus 4, y is going to be e to the power of sine cubed 3x plus 4. So I think I sometimes find it easier to not do the substitution. So what I'm going to do is write out what I think we should get, and then we'll see if we get that via the substitution. So I think we should have dy by dx is equal to, so it's going to be what we have, e to the sine cubed 3x plus 4 times 3 sine squared 3x plus 4 times 3 times cos of 3x plus 4. Okay, so that's what I think we should get from this. And all I've done there is I've done the chain rule in my head, which I sometimes find a bit easier. So I'm going to do it now properly with you guys. So again, we've got a function of a function of a function of a function kind of here. So hopefully we don't need to do it too many times over, because it will actually get more complicated like that. But okay, let's see what we can do here. So maybe we can do, let's say that u, to begin with, we'll say that y is equal to e to the v. So let's say v is equal to sine cubed of 3x plus 4. So from the chain rule, we're going to have dy by dx is equal to dv dx times dy dv. So dy dv in this case is going to be pretty straightforward. So dy by dv is just e to the v. So that's this first bit here. So we've already got that. Okay. So we now want, so let me write that. That's just e to the sine cubed of 3x plus 4. We now want dv by dx, where v is sine cubed of 3x plus 4. So I think the easiest way to see this is to rewrite, just for everyone, rewrite v is equal to sine of 3x plus 4 cubed. Now, here again we could use the chain rule on this bit, but I'm going to just hope that you can recognise that this inside differentiates to 3 cos of 3x plus 4. It is by the chain rule, but hopefully this is obvious at this point. If not, convince yourself of it. So I need dv by dx now, right? I've got this, I need this part. So let's let u equal sine of 3x plus 4. Then we know that dv by dx is equal to du by dx times dv by du. Okay, so let's work that out. So then from here we can see that du by dx is equal to, as I just said, 3 cos of 3x plus 4. Now, dv by du, well, v is equal to u cubed, so dv by du is equal to 3u squared. So hopefully you can see all of these pieces now in here that I did before. So they're all coming together. And we're going to have then, if we put this all together, dv by dx is du dx, so we just wrote that 3 cos of 3x plus 4, that was here, times dv du, which is 3u squared, and u is this, so that's going to be times 3 sine squared 3x plus 4. So this is dv by dx. So we've got our two pieces now. We have dy by dv and dv by dx. So this is dy by dv. So all I need to do is put everything together and I get dy by dx is dy by dv, which is e to the sine cubed 3x plus 4, times dv by dx. So that's going to be, I'm going to put the threes together, 9 cosine 3x plus 4 times sine squared 3x plus 4. Okay, and let's just check that agreed with what I said. Yeah. Fantastic. Okay, so that is it. That is all the questions. I know these ones were slightly more tricky, slightly more involved. But as you get better with these, as you do more practice, you may actually find it easier to do some of these questions without explicitly making the substitutions, as I did at the beginning. I wouldn't recommend doing it unless you get really comfortable, but it can start to be helpful. If you'd like to discuss it further, please again get in contact with me. You can find my email down in the description. And lastly, please, if you like the video, please give it a like and subscribe to the channel. There's going to be more videos coming out as everyone goes into their exams. It just means that you can stay on top of things, and if you'd like to have an impact and you want to tell me which things you want to see coming forward, then let me know. Make sure to join the Discord as well. The link is in the description. Otherwise, I'll see you in the next video. Thanks very much for watching.